Okay, so in chapter 2.4, we're looking at writing equations of lines. And so we really need the knowledge from the previous two sections to help us here. All right, first thing we want to do is look at three different methods in which we can do this. Now, this is taken from the book, page 91 in the Algebra 2 book. And the first one is what we call the slope-intercept form method. We've already done that before and use our understanding of if we have the slope, we have the y-intercept, then we can simply write an equation of a line. Now the other one is a little bit different. It's called the point-slope form. Now this is specifically used for when you have a slope that's been given to you and a point. And the x1 y1 just means it could be any point really. As long as the point is on the line and you have a slope, you can use this format of or this equation to work your way down to the slope intercept form equation of a line. Now technically you could use this as well, but sometimes this becomes more efficient, especially for those problem solving questions. So you want to know this formula as well. So this y is static, doesn't move. It's nothing that you're substituting into, and neither does this x. And you see that as we work it out. It's only this one, and this one that you substitute values in. So please keep that in mind. Don't mix those up. All right, and then we have the last one, 2 points. You basically know this already. If you have 2 points, you can use that to find the slope, and then from the slope, you can use that to either use the first one or the second one. So this one is always used in conjunction with the first two, either or. You could use the 2 points with point slope form or the 2 points with slope intercept form. All right, so let's go ahead and try this. Example 1 is writing an equation given the slope and the y-intercept. So pretty straightforward. This one, remember, we have y equals to mx plus b. So we need to find what the m is and also the b. Remember, your m is your slope. Now the b is easy to find. It's wherever it crosses the y-axis, so that's positive 3. And then from there, we can just count our rise over run. You can either go up or down. Remember, it doesn't matter as long as you choose another similar point where it crosses, right? So you can only pick those three to count to. Those two, rather. The other ones don't fit on the screen. You can pick this one because the y-intercept's not crossing at a spot like that. Okay, so you only pick the ones where they're intersecting. That's always the safest bet anyway. So let's count from either one. If we do rise over run and we go to the bottom one, that's going to go down to 1, 2, 3. So that's negative 3 over, this is going spaced out. So that's 1, 2, 3, 4. So rise over run is going to be negative 3 over 4. All right, and so then we just substitute into the equation y equals to negative 3/4 x plus 3. And remember, if you had done it the other way, this would have been if your rise, if you chose to not go with the one that we have here, but the y-intercept to the top one, remember, it's still the same. So if we count, that's 1, 2, 3, positive 3. So 3 over, and then 1, 2, 3, 4. Now, this is still the same thing. They're equivalent. You can write a fraction with the negative on the outside, on the 3, or outside of the fraction, like that, right? It's all equivalent. So either way, you get the same answer. Negative 3/4 x plus 3. 3 divided by 4, negative 3 divided by 4 is negative 0.5, and 3 divided by negative 4 is still negative 0.5. Okay, so next question. Using, you're given a slope and a point. Remember, with that, we're going to use the point slope form. You can use the first one if you're algebra savvy, but the point slope form makes it easy. And sometimes, if you're doing entrance exams, they have some problem solving in there, and it's better to use the point slope form. So make sure you understand how it works. Remember, it's y subtract y1 equals to your slope times x subtract x1, where the y1 and the x1 represent the real dynamic points there. Oops, I put 2. All right, so we have our slope. M is equal to 2/3. So we just substitute that in there. Y subtract y1, that's negative 3, equals to m, that's positive 2/3. x always stays the same there, the first x, and then x1 is 1. Let me just simplify. These are two negatives, so that becomes y plus 3. We can distribute, so that's 2/3 x minus 2/3. All right, and then we can subtract the 3 on both sides. We're going to subtract it with that fraction, and hopefully your fractional arithmetic is good. So that's 2/3 x minus 2/3 subtract 3, and 3 can be written as 3/1. Remember, to subtract fractions, you want to make your denominators the same, and so you could times that by 3 to make your denominators the same there. And then if we come back to our blue, darker blue, y is going to be equal to 2/3 x minus, let's just put this on the side. 3 times 3 is 9, and 3 times 1 is 3, so 9/3. So -2 subtract 9, it's going to give us -11. Make sure we do that correctly. -2 subtract 9, right? This, let me just rewrite it so you're not confused. That's going to be -9/3, and the identity is going to be 2/3 x. Subtract the 2 and the 9. Remember the numerators, we subtract -11. The denominator stays the same. And so we have m is equal to 2/3 as we see up top, and our y-intercept is -11/3. All right, so that's how you would do that example. This one here, write an equation of the line that passes through 1, 2. Now this is a two-part one, so for A, they want it for perpendicular and then parallel. So what this is literally saying to you is that, let's say you had a graph here, and let's just say the first line went to 1, 1, -2 would be about here. Then the other one is -4, 3. Let's just say it's that, right? They're saying find the equation of the line that's perpendicular to that. Perpendicular. So they basically want that line, right? What is perpendicular to that line? So perpendicular and parallel to y equals to -4x plus 3. So that's our starting point. So part A wants the perpendicular intersection, right? And that little symbol there, we use that to say perpendicular. So the first thing we need to do is find what the slope is. Remember, perpendicular slopes, and I'll just use that to represent perpendicular. So this is how we find the perpendicular slope. It is equal to the negative reciprocal of whatever line we're comparing it to. Now the line here is m equals to -4. So the perpendicular slope, remember, that's the negative reciprocal. So that's going to be 1 over +4. So that's our perpendicular slope. Now it passes through the point 1, -2. So we have a point and we have a slope. So we could use the point slope formula. And if we do that, we can find out what the equation of the line is that's perpendicular to y equals to -4x plus 3. And so we have y subtract our y1, which is -2, equals to m, which is 1/4, x minus x1 is 1. So that becomes y plus 2 equals to 1/4 x subtract 1. Right, we bring the 2 over by negating it. So we have -1, it's supposed to be a fourth. We have a -4th subtract 2. And instead of writing 2, remember it's 2/1. And so if you times that, it becomes 8/4. And 8/4 is 2, right? So that way, registered in one step. And at this level, you should be able to follow. So that's the fourth x. -1 minus 8 in the numerators becomes -9. And in the denominators, 1/4, a 4. And some notifications. All right, so that's our perpendicular equation to that line. All right, let's try part B. Part B is asking something similar, but it's parallel. So if m is equal to -4 there, then our parallel slope here, that's supposed to be a parallel line, m parallel, our parallel slope, put those parallel lines vertical. So our parallel slope, and don't think that's 2, that's like just to denote that's our parallel one. Our parallel slope will also equal to -4 And so once again, I have negative 4. I have the point. That's a point slope. My slope is 1, negative 2. So I could use the point slope formula. Y subtract y1 equals to m times x minus x1. That's y subtract negative 4. Oops, that's my slope. Let me be careful there. Let me label it x1, y1. So that's y subtract negative 2 equals to our slope, negative 4 times x stays the same, subtract 1. Right here, that becomes y plus 2. The negative 4 can distribute into the quantity, and then we subtract on both sides from the 2 from both sides. And we're going to have positive 4, subtract 2. And this one, no fractions really. Negative 4x, 4 minus 2 is just positive 2. And that's our parallels line. And remember, we talked about that before, that the slopes will be the same, the y-intercepts change. And so this one is parallel, and then the other one is perpendicular. And these are perpendicular and parallel to that equation. All right, so let's go ahead with example 4. We're going to write the equation of the line given 2 points. Now, what do we do when we do this one? Well, we could find the slope between the two. Remember, that's the third option there. All right, so first thing we want to do is label this x1, y1, x2, y2. So to find the gradient, we're going to have 2. Remember, y2 subtract y1. So 2 is y2, subtract y1 is 1. x2 is negative 3, subtract x1, that's 4. So that's going to give us 1 over negative 7, as we learned before. And so that's our slope. Now we can choose one of our points there. It doesn't matter which one. Both of them will give you the same answer. So I'm going to circle that one in purple, and we can use the point slope. We have a slope and 1 point. So using y subtract y1 equals to m times x minus x1. And substituting in what we have y1 is going to be 1 in our case. M is 1 over 7, negative 7th, times x minus x1 is 4. All right, if we distribute in there, on the right side, we're going to have negative 1 over 7 or 1 over negative 7, either one. And then the 1, that's going to turn to a positive, and then we have there 4 over 7. Right? And on the left side, we still have y subtract 1. All right, so then we're going to add 1 on both sides, and just for space, I'm just going to write it right next to it. So we're going to have plus 1 over here. 1s will cancel. And when we add the 1 over here, I'm just going to skip a step to 7 over 7, which is the same as 1. All right, so we're going to have y is equal to negative 1 over 7 x plus 7 plus 4, that's going to give us 11 over 7. All right, and so that would be our final answer there. Y equals to negative 1 over 7 x plus 11 over 7. All right, so now let's go ahead and try the second one, and it doesn't matter which one you use, you still get the same answer. So I'll change the color here to light blue. And so using the same thing, point slope, we have y subtract, and in this case our y1 is going to be 2. So y subtract 2, and that's going to be equal to our slope, which is negative 7th, x minus our x2, which is negative 3. All right, that's going to change it to a positive. And so what we're going to have here is negative 1 over 7 x plus 3. And then we can distribute. So we have y subtract 2 is equal to negative 1 over 7 x. And then that's going to give us negative 3 sevenths. All right, and so we're going to add 2 on both sides. And I'm just going to add the 2 up here. And that can be written as 2 over 1. So here we'll just cancel. And so we're left with y equals to negative 1 over 7x minus 3 sevenths plus, and hopefully you can see it in your head. If not, let me just write it out here. I'll times this by 7, times that by 7. And then if I change the color back, we have 7 times 2 is 14 over 7. Now the negative 3 plus the 14 in the numerator is going to give us 11, positive 11. And the denominator stay the same. And so you see you still get the same answer no matter which one you choose. And that's how you can do it when you're just given 2 points. All right, so this one here is kind of a doozy. Write an equation of the line that passes through 2, negative 5 and is perpendicular to the line that passes through 3, negative 7 and 4, 6. All right, so we have a question here, and we just want to try to break it down to know what we're doing. The equation of this line is going to pass through this point. So we know we need to have a slope and a point in order to do this. So we need this slope here. But this slope is going to be perpendicular to whatever slope passes through this. So that means I have to find the slope of this, then find the perpendicular slope, and then use the perpendicular slope with the point in the point slope formula in order to get the equation that is perpendicular to those 2 points. All right, hopefully that made sense. And so sometimes trying to draw it out can make sense for you as well. But even using the words and a cognitive approach, a cognitive map can help. So let's go ahead first and find the slope of these 2 points. And remember, it always helps to label these. If you don't need to, that's good, but most mistakes that happen come from a mislabeling. So the original slope is going to be our y2, which is 6, subtract our y1, which is negative 7, over our x2, which is 4, subtract our x1, which is 3. The 2 negatives there make a plus, so that's 13 over 1, or just 13. Now a perpendicular slope is the negative reciprocal of that, which is going to be, if you reciprocate the 13 over 1, 1 over negative 13. Now the negative can go on either one. As you saw when we did with slopes, we can negate each one to go up or down. All right, so that's our perpendicular slope, and it passes through 2, negative 5, so we have our other point, 2, negative 5, and that could represent the x1 and y1. All right, so let's go ahead and use that formula. Y minus y1 equals to m times x subtract x1. Our y1 is negative 5. Our m is negative 13ths. Our x, the first x is static, stays the same, and then minus 2. We can distribute in. So on the right side, that's going to be negative 13th x plus 2 over 13. Over this side, that's a y plus 5. And because there's 2 negatives, make a positive. Subtract on both sides. I'm just going to subtract it here. Remember, it can be written as 5 over 1. So we're left with y on the left side equals to negative 1/13 x plus. Now we need to make the denominators the same, so I'll times this by 13 and also the numerator by 13. 5 times 13 is going to be 65. And so we're going to have here 2/13 subtract 65 over 13. So we could write the final answer up here. Y equals to negative 1/13 x. And this will end up being negative. If I add 2 to negative 65, that's going to be negative 63 over 13. And that's our final answer for that one. Remember, for questions like those, try to formulate a little map there to assist you.